Seismic activity is also one of the most important sources of information about the interior of the Earth. In this video, we're going to read about the earthquakes. So what is an earthquake? It simply means shaking of the Earth. It is caused due to release of energy, which generates waves that travel in all directions. Now the question is, why does the Earth shake? To understand that, you will have to look at this picture. This is a fault. A fault is a sharp break in the crustal rocks. Rocks near a fault tend to move in opposite directions. That creates friction, but at some point of time, their movements overcome the friction. As a result, they slide past one another. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake, or there is also a term given to it called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. This place is the first one to experience the waves. All natural earthquakes take place in the lithosphere. The lithosphere refers to the portion of depth up to 200 km from the surface of the Earth. An instrument called seismograph records the wave reaching the surface. The waves look something like this. The curve shows three distinct sections, each representing different types of wave patterns. We'll get back to this pattern in a moment. Earthquake waves are basically of two types, body waves and surface waves. I need you to understand the term body waves. Sounds a little larger within the body, right? So the body waves are generated due to the release of energy at the focus, that is the epicenter, and moves in all directions, traveling through the body of the Earth. You know, it travels internally within the Earth's surface and moves the interior of the Earth. That's why it is referred to as body waves, because it is traveling through the body of the Earth like a tremor. Now it is obvious that when these body waves move towards the surface, they will come in contact with the surface rocks and generate new set of waves. These are called surface waves. Now the velocity of waves changes as they travel through materials with different densities. And we know that the materials with higher density recede downwards. Therefore, the denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. That's why when the seismic waves reach towards the surface of Earth, there the materials are of lower density, and that slows down the intensity of the waves, leaving behind a fault. Now going back to the picture that I showed you, so if you look at this picture, there are two types of body waves. They are called P and S waves. So the letter P and S stands for primary and secondary. Now you can relate when I say primary, they are the first one that gets recorded on a seismograph, the instrument. And then comes the secondary wave. You can look at this illustration to understand how these wave looks. The P wave, that is the primary or pressure wave, is a pulse of energy that travels quickly through the Earth's solid materials as well as liquids. It forces the ground to move backward and forward as it gets compressed and expanded. The S wave, that is the secondary or shear wave, follows more slowly with a swaying, rolling motion that shakes the ground back and forth perpendicular to the direction of the wave. If at all the concept of P and S wave isn't clear to you, I recommend that you watch this video by Dr. Keith Miller, where he physically demonstrates P and S seismic waves. The video by him is extremely helpful. I'll link the video in the description and you can go and have a look at it. Now going back to this picture, after body wave, that is P and S waves, comes the surface waves. The surface waves are the last to report on seismograph. They look something like this. This wave spreads across the surface of the Earth. These waves are also more destructive and damaging. They cause displacement of rocks and hence the collapse of structures occurs. If you want to see more of such educational content, make sure you're subscribed. By doing so, you'll get an alert when my next video comes. Thanks for watching, and I'll see you in the next one.